This is the Geometry Unit 1 Lesson 3 video. These videos and this lesson are all about measuring line segments. And so it's going to take us through some, just give you an idea of how we measure line segments and some of the terminology and notation that you need to be aware of. So they kind of begin with this concept of what they call the ruler postulate. And I'm going to just jump over here and talk through what the ruler postulate is all about. The ruler postulate is really just a way of describing the way that we measure line segments. So it says, and there's a lot of words here, I'm going to read this and then I'll kind of unpack it. The points on any line or line segment can be put into one-to-one correspondence with real numbers so that two selected points can have coordinates of 0 and 1. And the distance between those points is an absolute value of the difference between those numbers. That is a mouthful. What it really means is that if I have some numbers, or I have some points that are in a line, I'm sorry about this, it's having a hard time loading. Let's try it one more time. There we go. And I want to measure the distance between these 2 points, D and F, for instance. I can measure that distance by looking at the difference between 3 and 2. In a sense, 3 minus 2 equals 1. Therefore, the distance here is 1, in this case, 1 inch, I suppose. And that is really what the ruler postulate is all about. It's just a way of describing what happens when we measure things. So just to kind of drive that point home, if I were to choose B and H has a value of 4, B has a value of 1. 4 minus 1 equals 3. So the distance between those points is 3 inches. And that's really how the ruler postulate works. So you're more or less going to be doing that for some of these problems. There can also be half units. It doesn't have to be a whole number. So for instance, just as one last example, if I have C and F that I want to look at, F has a value of 3. C is at 1.5. It's halfway between 1 and 2. So then 3 minus 1.5 is also 1.5. And so the distance between C and F, or the measure of this line segment CF, is 1.5 inches. So I kind of made a turn there at the end and said, this line segment between C and F is an example of a geometric figure that connects directly to this idea. So we have line segments that can be measured in the way that we measure things with a ruler. So CF would have to have a measurement of 1.5. So this is more or less what you're going to be doing in the first part of this lesson. So let me scroll down here. Obviously, you have a bunch of vocabulary words. So definitely read through the vocabulary. There is a bunch of terms at the top of the page here that you can use to answer those. So just utilize that. Utilize the Control F function. And that's going to get us through the first 5 or 6, more like 8. And then it gets us to some ruler postulate questions. So like in this first one, they want you to measure the distance between D and F. So utilize what I told you in the kind of brief introduction to answer that. Same thing here, D and H. What's the difference between those 2 points? What's the distance between D and H? Same thing with number 11. All right, then we get to number 12. And number 12 is an example of what we call the segment addition postulate. The segment addition postulate. Segment addition postulate says that if I have this line segment, let me do that let me do it with different points. I have this line segment and it has 3 points. It has a point here, a point here, and a point here. Let's call those points A, B, and C. Then I can say that amongst those 3 points and the 2 line segments that they make, there's a relationship. And that relationship is that AB plus BC equals AC. In other words, the points between A and B, the points between B and C, add up to the points between A and C. So if I were to say, okay, AB is 12 and BC is 5. So if AB equals 12 and BC equals 5, and then we use this little formula here that we made, that is an example of the segment addition postulate. It tells us that 12, which is the length of AB, plus 5, which is the length of BC, will tell us the length of AC, which is, in the diagram, the length from here all the way to here for the length of the entire line segment, which is pretty basic adding, but 17 would be the length of the entire line segment AC. And so it seems kind of like an obvious concept, but that's just kind of one of those fundamental things that you have to understand. Now, we could look at this sort of in reverse. So what I mean by that is, let's say I have this line segment, and I have 3 points. Do one there, there, and there. Let's call these M, N, and O. And let's say that we know already the length of MO is 34. And we know the length of NO is 10. So in a similar sense, I can use the segment addition postulate idea to solve the answer to this, because I know that MN plus NO equals MO. Another way of looking at that would be to say that if I already know MO, I could subtract one of the parts to find the other part. So let's look at how that works out. So we don't know MN. MN is the thing that we don't know. So what plus 10, which is the measure of NO, will give me 34. So like I said, the real way to think about this is sort of algebraically. We could say this is x. X plus 10 equals 34. X equals 24. And that would be the measure of MN right here. MN would have a measure of 24. All right, so looking back at the lesson, that's exactly what you have to do in number 12. They've given you information about these different distances. You need to find the missing distance right here. I think you'll be able to handle that using that example I've just done. All right, now we get to some questions that introduces another concept. And that concept is bisectors. So a bisector, or to bisect, literally means to cut in two, because sect means to cut, and bi is from the Latin word for two, so it means to cut into two equal parts. Cut into two parts. And in this case, they're going to be equal. So I'll just change that to say cut in half. So in this diagram, you're given all this information. You're given a diagram, and then you're given the information that mx is equal to xn. So that would be referring to this part and this part. So we're saying those are equal. And then what you're going to have to do is you're going to have to answer some questions. So I'm just going to jump back over to the lesson so you can see. I've given you a diagram very similar to what you're given in number 13 through the end. So let's talk through the different questions. First thing it asks is name two line segments that have the same length. Okay, so in geometry, saying that two line segments are congruent, like we have here, where it says mx is congruent to xn, is one way of saying something. That's saying that the two objects are the same. But if I wanted to talk specifically about their lengths or the measurement of how long they are, I would say mx is equal to xn. So it's kind of a weird concept, but when we use this symbol, congruent, it's a way of looking at, sorry about that. Congruent always refers to objects, angles, line segments, triangles, things like that. Whereas when I use the equal sign, equal, I'm referring to measurements. So it's important that we kind of understand the difference between those two concepts. So keep that in mind, because that's what we're doing in this first one. These two statements might seem the exact same, and they, in a way, they are the same idea. But the first statement, mx, line segment mx, is congruent to line segment xn, what you see the blue box around. That is an example of a congruence statement. Whereas what you see here, mx is equal to xn, that is what we call an equality statement. So we need to say these separately sometimes. And so that's all they want you to do in number 13, is they want you to take this fact right here, and you need to apply it, name two line segments that have the same length. All right. So that information is key. This is your key to answering this question. Hopefully you'll catch my drift. What is the midpoint? Which point is the midpoint of a line segment? Jumping back to my diagram here, if mx and xn are the same length, that makes x a midpoint, meaning it is the point in the middle. So it's going to be point x. So again, I'll let you use that information to answer. It's going to be the midpoint of the thing that's being cut in half, which you see right here. So I think you'll connect. Make sure you're looking back and forth as you go, because I'm basically walking us through these questions. Number 14, find the midpoint in the way that I found the midpoint here. Which line is a segment bisector? Well, in my figure here, the bisector is, I'm going to do that in the same color here. The bisector is going to be BA, because BA cuts this in half. So I'm going to say that right here, BA is a bisector. So you need to find in your diagram, what is the bisector in this diagram right here. All right. Number 16, if AY equals 4, what is the measure AC? So let's jump back over here. So let's say we're back over here, and I'm going to redraw this diagram again. Just grab all this. I think I got it all. No, I didn't. It's okay. Let's redraw it. We have these things. We have BA, we have X, M and N. All right. All right. So let's say they told me and MX was 7. Okay. mx is congruent to xn. We already knew that. But suddenly they tell me that mx is equal to 7. What is the measure of AC? That would be like me asking, okay, if that's true, what is the measure of mn? Well, if this is 7, that means this is 7 because they are congruent, which means that the entire length using the segment addition postulate is 14. Again, I'll let you make the connection between that and number 16. Then it says here, calculate the length of segment AB with midpoint M if AM equals 5. Again, we're back. You should be looking at the same diagram, okay? Or no, actually, this is getting us a new diagram. I'll draw the diagram for us. So we have segment A, B. It has a point here, M, which is the midpoint. And it tells us that AM is equal to 5. And then it asks, what is the length of the entire line segment? A to B. And since M is the midpoint, it means that these two are equal. And so you should easily be using that information, be able to find out what the length of MB is. And if you know the length of MB, then you know the length of the entire thing, AB. So I'll let you use that diagram. Make sure you pause the video so you can go answer that. Last question, calculating things of RS. We have R and S with a midpoint M. RM equals 5x and MS equals x plus 12. So one thing we know for sure, if M is the midpoint, that means this and this have the same length. Another way of saying that would be to say that 5x equals x plus 12. Now this is an algebraic equation, and you need to solve to find out what x equals. What does x equal? So you should be able to solve that. If you need help with number 18, please reach out to me, and I will post something about it later on. But you should be able to solve that equation to find x, and then use x, the answer you get for x, to plug it into those two x's and find the actual length of the line segment. That's a little bit of a challenge. I would like you to attempt it. Use what I just gave you right there. Make an attempt, but reach out to me if you really have no idea what to do. And I will post a solution for you guys next week.